Hello everyone, welcome to this video. In this video, we shall see some more problems on the directional derivatives that we have learnt in the last video. So here, the first question is, we are to calculate the directional derivative of x square yz plus 4xz square at the point 1 minus 2 minus 1 in the direction of 2i cap minus j cap minus 2k cap. So this is the given question. Now this is a very simple question. You are given this function whose directional derivative is to be found in this particular direction. So the first thing, we know the formula. If we assume phi of x, y, z to be equal to this function x square yz plus 4x z square, so then we can compute this gradient of function phi. So that would be equal to del by del x I cap plus del by del y j cap plus del by del z k cap of the given function x square yz plus 4xz square. So that means when you take the partial derivative with respect to x of this quantity, so it would be 2xyz plus 4z square. So this quantity I cap plus when you take the partial derivative of this whole function with respect to y, so it would be x square z, right, into j cap, because there is no y term here. And for the third quantity, we'll assume x and y to be constant. So when you take the derivative partially with respect to z of this quantity, so you will end up by the terms y square x square y plus 8xz into k cap. So this is your gradient, and moreover we are to evaluate this gradient at the given point 1 minus 2 and minus 1. So accordingly, our gradient of phi evaluated at the point 1 minus 2 and minus 1, this is going to be equal to, so in place of x we'll write 1, in place of y we'll write minus 2, in place of z we will write minus 1. And so similarly for every term we'll do the same. So this is our term with I cap, and then we have the term with j cap, and then finally the term with k cap, right? So plus 8 into 1 into minus 1 into k cap. So when you solve this, you will have the value, we have two negatives, so it would be 4 and plus 4 I cap, and then so basically it is 8 I cap. So it is 8 I cap, and this quantity is minus j cap, and this quantity minus 2 and minus 8, so this is minus 10 k cap. So this is our first thing that is required. Moreover, we are to take the directional derivative in this direction, so that means we are to calculate a unit vector in this particular direction. Therefore, if we assume, let the vector a is given to be 2i cap minus j cap minus 2k cap. This is the direction in which we are to calculate the directional derivative. So the unit vector would be the vector a divided by its magnitude. So this would be equal to 2i cap minus j cap minus 2k cap divided by the magnitude, that is 2 square plus minus 1 square plus minus 2 square, taking the square root. So this would be 2i cap minus j cap minus 2k cap divided by 4 plus 1 plus 4 square root. So this would be equal to 2i cap, or sorry, 2 by 3 I cap minus 1 by 3 j cap and minus 2 by 3 k cap. Now this is your equation vector 2. Now in order to calculate the directional derivative of phi at the point given point 1 comma minus 2 comma minus 1 in the direction of vector a, in the direction of vector A. So this is going to be equal to the gradient of phi evaluated at the point 1 comma minus 2 comma minus 1 dot product with the vector unit vector A cap. So we have this first as 8 I cap minus j cap minus 10 k cap. So this is equal to 8 I cap minus j cap minus 10 k cap dot product with another vector, this one. So you have 2 by 3 I cap minus 1 by 3 j cap minus 2 by 3 k cap. So when you take the dot product, this would be equal to 16 upon 3 plus 1 upon 3 and then plus 20 upon 3. So this would finally become equal to 37 divided by 3. So this is the value of directional derivative in the direction of vector A. So the thing that is most important here is, do not forget to calculate unit vector. If you take the dot product of the given vector itself, your result would be incorrect here. Okay, so now let us move on to our next problem. So let us see question number 2. It says that for the function phi, which is given to be x square y cube z to the power 4, you are to calculate the directional derivative of phi at the point 2, 3, 1 in the direction making equal angles with x, y and z axis. So this is our question. So that means the surface is clearly given to you, but the direction is not given to you. In order to calculate any directional derivative, you require three things. One is the given surface, which is a scalar point function, right? A scalar point function. Second thing that you require is the point at which you wanted to calculate, so the given point. And third thing is required to be the unit vector in the given direction. Unit vector in the given direction. So in this question, if you look at this problem, here the surface is given to you. This is given to be this phi is equal to x square y cube z power 4. Point is also given to us, which is 2, 3, 1. But unit vector in the given direction, that is not given. Actually, the direction is also not given exactly. They have just told you direction making equal angles with x, y and z axis. So here you have to do some mathematics and you have to firstly compute this particular direction, and then you will find what is the unit vector in that particular direction. Okay. So here, in order to determine that, if we assume a cap to be the unit vector, let a cap be the unit vector in the direction which makes an equal angle alpha with the positive x, y and z axis. So what would be that? If I have assumed this angle to be alpha, so in that case our direction would be cos alpha with respect to the direction cosines would be what? They would be cos alpha with x-axis, cos alpha with y-axis and cos alpha with z-axis, because they are making equal angle. Therefore, the direction cosines would be cos alpha and cos alpha. So if the direction cosines are these, and you know the square and sum of all the direction cosines, that forms equal to 1. So you have cos square alpha plus cos square alpha plus cos square alpha, that becomes equal to 1. So you could write 3 cos square alpha, that is equal to 1. From here you can obtain cos alpha's values as equal to 1 by square root 3, right? So this is the, from here you obtain the value of alpha. This is equal to cos inverse of 1 by square root 3. So basically your direction in which you wanted to calculate the unit vector, this would be equal to cos alpha I cap plus cos alpha j cap plus cos alpha k cap. So this becomes equal to 1 by square root 3 I cap plus j cap plus k cap. So this is the direction unit vector in the given direction. Next thing that you wanted to calculate is the gradient of the given surface at the given point. So this is equal to, so what is this? If you calculate the gradient of phi, it would be del by del x I cap plus del by del y j cap plus del by del z k cap of the given surface x square y cube z power 4. This comes out to be equal to 2x y cube z power 4 I cap plus 3x square y square z power 4 j cap, and then with respect to z it would be 4x square y cube z cube. This, I hope you know how to calculate the partial derivatives. Okay, this is the gradient. Now we are to calculate this gradient at the point 2, 3, 1. So this would be obtained from this when you substitute the value of x as equal to 2, y as 3 and z as equal to 1. So it would be 2 into 3 to the power 3 and then 1 to the power 4 I cap, 3, 2 to the power 2, 3 to the power 2 and then 1 to the power 4 j cap plus 4 times 2 to the power 2, 3 to the power 3, 1 to the power 3 k cap. So when you evaluate this quantity end up as 108 I cap plus 108 j cap plus 432 k cap. So this is the vector that is required in order to calculate the direction derivative. Therefore the directional derivative, that simply becomes equal to the value of gradient calculated at the given point 2, 3, 1 dot product with this vector A, unit vector in the given direction. So this becomes equal to 108 I cap plus 108 j cap plus 432 k cap dot product with the unit vector, that is 1 by square root 3 I cap plus j cap plus k cap. So when you take this dot product, it becomes equal to 108 by square root 3 plus 108 by square root 3 plus 432 by square root 3. So this becomes equal to 648 by square root 3. So this is your final answer, right? So I hope this question is also clear to you. Okay, now so let me move on to the next question here. Question number 3. It states that find the directional derivative, find the directional derivative of f of x, y, z, which is given to be x, y square plus y, z cube at the point 2, minus 1, 1 in the direction of normal to the surface. The surface is given to be x log of z minus y square is equal to minus 4 at the point minus 1, 2, 1. So here you should identify what is given to you first in order to calculate this directional derivative. So you are to calculate the directional derivative. So that means this is your scalar point function f at this point. So point is given to you, the surface is given to you. So in order to calculate the directional derivative, we have to perform this the del of the given surface, that is f, computed at the point 2, minus 1, 1, dot product with the unit vector. We shall see what is a unit vector. First of all, let me calculate this del of f. Now f is given to be this, so I have to compute del by del x I cap plus del by del y j cap plus del by del z k cap evaluated for the function xy square plus yz cube. So this becomes equal to y square I cap plus 2xy plus z cube j cap plus 3yz square k cap. So this is the gradient, and we have to evaluate this gradient at the given point. The given point is 2, minus 1, 1. So we have to substitute the values here. It comes out to be equal to I cap minus 3j cap minus 3k cap. So this is one thing that is required. Now look at the other part for this question. They say the direction of the normal to the surface this. So this is another surface that is given to you. This is the given point, and you are to calculate normal to the given surface. And if you remember, the gradient, the quantity gradient, give you the normal to the given surface. So here we will calculate the corresponding gradient of this surface. Suppose let me call this to be the surface G. So if you calculate the gradient of this surface, so that will give you this direction, which is the required direction. So if I calculate gradient of G, this becomes equal to So if you calculate this gradient G, that means you are calculating del by del x I cap plus del by del y j cap, del by del z k cap. This operator you are applying on to the given surface x of log of z minus y square. So what would this would come out to be, if you take the partial derivative with respect to x, it would be log of z I cap, right? With respect to y, it would be minus 2y j cap, and with respect to z, it would be x upon z k cap. And when you evaluate this at the given point, the given point here is the second point which is given to you. So let me show you. This is the point. So minus 1, 2, 1. Okay. So the given point is minus 1, 2, 1. So when you substitute this point here, this is log of z, not g. Okay. So when you substitute this point here, this would be equal to log of 1, that is 0, so 0 I cap, minus 2 into 2. So you have minus 4 j cap plus the value of x, that is minus 1, the value of z is 1, so you have minus 1 k cap. So this is the quantity in which we want, this is the given direction. Now we have to evaluate unit vector in the given direction. So what would be that? It would simply be this vector minus 4 j cap minus k cap divided by its magnitude. So it would be square root of minus 4 whole square plus minus 1 whole square. So this is equal to 16 plus 1, that is 17, square root of 17. So we have minus 1 by square root of 17 and the quantity 4 j cap plus k cap. So this is the given direction. So say this is your equation number 2. Okay. So now next thing is we are to calculate the directional derivative. In order to calculate the directional derivative, So what we have to do? We have to take the dot product of the given vector f, which is given by our equation number 1 at the given point 2 minus 1 1, dot product with this vector. Say I am calling this to be the a cap vector, right? So I have to take this dot product over here. So this is equal to the first vector that which we calculated was equal to I cap minus 3j cap minus 3k cap, dot product with this vector, which is minus 1 by square root 17 into 4j cap plus k cap. Okay, so this becomes equal to 1 by square root 17, and we have 0, right, because here there is no I, so 0 into 1 is 0, then plus minus 4 into minus 3, that is 12, and then minus 1 into minus 3, that is 3. So it is equal to 15 by square root 17. So this is the value of directional derivative which we wanted to compute here. So I hope you got a pretty good idea of how to calculate directional derivatives for different quantities. So well, that is it for this video. Thank you for watching.